This problem here is much more easier to do, I think, than the last problem we did. So if you followed through on the last problem, what you need to do is write this down, pause, and try to work this out yourself, and then see what you get for the final answer. But I'm going to go ahead and work it. So remember that we always do the direct substitution, plugging 0 directly in and seeing what we get. In this particular case here, instead of doing that right off the bat, I'm going to try to simplify this down. And I'm going to write this tangent theta in terms of sines and cosines. So rewriting the limit as theta goes to 0, we have cosine theta times, now remember tan theta is sine theta over cosine theta, and that's all over theta. Well, you can see that up here in the numerator we have a cosine theta in the top and one in the denominator, so we can just cancel those out. So now we're left with the limit as theta goes to 0 of sine theta over theta. Now this is one of those ones that you just had to remember. We kind of defined that the limit of theta as approaches 0 of sine theta over theta is equal to 1. Therefore our original limit here is equal to 1. And that's not too bad. Let's work out another one here, since that didn't take very long. Let's say we've got the limit as x goes to 0 of 2 tan squared x over x. Now I'm going to rewrite this tan squared x. I'm going to get this in terms of sines and cosines again. So we have sine squared x over cosine squared x, and of course that's all over x, and don't forget to rewrite the limit. Alright, we don't want to forget that. And it even helps, let's say that it's because this limit is still equal to this one. Alright, so now I'm going to break this up. I'm going to take this 2 and bring it out front. So we're going to kind of skip some of the intermediate steps, and hopefully you can kind of keep up with that. I can rewrite this as the sine x over x times sine x over cosine squared x. Now hopefully you can see where this is coming from, right? I take the 2, I bring it out front, I break this up. This is sine x, this is cosine. I go ahead and keep the cosine squared x. But remember, I can take this fraction up here and drop it down. And so we end up with a sine squared x in the numerator and then an x times cosine squared x in the denominator. That should kind of help you figure this out. So I break up the sine x, since there's 2 of them in the top. Here's one of them, and then here's the other. And there's my cosine squared x. And I don't know, sometimes it kind of helps put brackets around everything. Okay. So now we can evaluate these separately. This is 2. Now remember, we defined what sine x over x is. As long as x is going to 0, this is going to end up being 1. And sine of 0 is 0, and cosine squared of 0 is 1. And so we end up with 0 over 1, which is 0. and we get 0 again. Seems like in a lot of these problems we're getting 0, but that's just the way it's turning out. So we could say then that this limit is equal to 0.